graphing lines. Okay? First way, slope and y-intercept. Okay, in this case, you're going to have an equation, y equals 2x plus 3. We need to remember that 2 is our slope, and plus 3 is our y-intercept. So what I'm going to do is draw some lines first. Because I paused while doing that, the lines should just appear for you. Make sure you're labeling your Cartesian plane. So remember, x sits on the line. There's our positive x and our negative x. Y hangs down. There's our positive and our negative y. So first things first here, what I'm going to do is I'm going to plot my y-intercept. So that means I'm going to go along my y-axis and plot a 3. So there's my y-intercept. Now I'm going to move based on my slope. So we remember that slope is rise over run. So that means our rise in this case is 2 and our run is 1, because really there's a denominator of 1 there. So I go up 2 over 1. Up 2 over 1. And of course you would have a ruler, so you would be able to extend this line and draw arrows really, really nicely. And that's how you graph using your slope and y-intercept. The next example is by using your intercepts. So 2, graphing using intercepts. So in this case, I'm going to use an example from the book. So it's 3x minus 4y equals 12. In this case, what you're going to do is find your y-intercept and your x-intercept. Remember, to find your y-intercept, you're going to say that x is equal to 0. And to find your so let's do this first. So this is for our y-int. So y-int, we're going to say x equals 0. So it's going to be 3 bracket 0 minus 4y equals 12. 3 times 0 gives me 0, so I'm just left with 4y equals 12. Divide both sides by negative 4. And I'm going to come up over here because I ran out of room. Y is equal to negative 3 in this case. So that's my y-intercept. Next, I'm going to do my x-intercept. And in order to get my x-intercepts, my y will be 0. So again, I'm using the equation 3x minus 4, it's not y anymore, it's 0, equals 12. I now have 3x, negative 4 times 0 gives me 0, so that's gone, equals 12. Divide both sides by 3 to eliminate my x. X in this case is equal to 4. Now I can plot both of these intercepts and then graph. So I come back up to my graph again. I'm going to do x first, just because I'm comfortable with that. I go over to 4, 1, 2, 3, 4. And I plot my point. I then go to y is negative 3, 1, 2, 3, down to negative 3. Again, with a ruler, you are now going to connect these points and draw past them to extend the line. And that's the second way of graphing, by using the intercepts. And then the third way is going to be just using a table of values. So again, if I have an equation, x plus y equals 6, I'm going to create my table of values. In this case, x and y, I generally said do negative 2, negative 1, 0, 1, 2, and I stick to that. What you're going to do in this equation, what I would do is I'm going to rearrange the equation. So it's y equals 6 minus x, because I'm going to be plugging in values for x. So first case would be 6 minus x, which is 6 minus minus 2. Remember, these two negatives become a positive, so you have y equals 8. So my y value would be 8. Now I'm going to go for my next term, so it's going to be 6 minus minus 1. Again, become positive, so I get 7. Next, sorry, put the 7, and so on. I will keep going until I fill my table of values. So my next one would be y equals 6 minus 0. So my answer is 6. put 6 up. Y equals 6 minus 1, so y is 5. And last but not least, y equals 6 minus 2, so y equals 4. Now you need to graph these. Hopefully the lines just appeared for you, and again we're going to label, putting our x is on their axis of positive and negative, y on their axis, positive and negative. And now above I have my table of values that I've just circled that I'm going to plot the points. So I'm going to go over -2, up 8. 1, 2, 3, 4, 5, 6, 7, 8, and I just make it. -1, 7, so that's just down here. 0, 6. 1, 5, and 2, 4. Again, you would use a ruler extending this line, because we remember that I could have any number of ordered pairs which could make this line infinite.